310A says, consider the setting of exercise 3.9 part A. It says, suppose that a woman tests positive. What is the probability that she really is pregnant? So in 3.9, I'm sorry, this is now 310. 3.9, we found out the probability of testing positive. Now we want to know, if she tests positive, what's the probability that she is actually pregnant? So what is the probability of being actually pregnant given that she tests positive? Okay. This means out of those who test positive, we've got this group, those who are truly pregnant and test positive, and we also have this group, those who are not pregnant and still test positive, for a total group of size 0.107. We want to know, out of this 0.107, how many are truly pregnant. So those who are truly pregnant, so the formula for this will be those who are the probability of being truly pregnant and testing positive divided by the probability of testing positive, which is what we did in the previous exercise. So in this case, we have on the bottom we have 0.107, and on the top we have 0.10 times 0.98. This is the women who are truly pregnant and test positive divided by all the women who test positive. So 0.098 divided by 0.107. And that is equal to 0.916. Okay, so this implies that if you were if you tested positive in this group, the chance that you are actually pregnant is 0.916. That's not 100% because in the population or the group of 1,000, only 10% are women. So if you test positive, you might be part of the 10% who are truly pregnant, or you might be part of the this group that tested positive even though you weren't actually pregnant. Okay. Part B is very similar, except we have different numbers. Instead of 0.10 and 0.9, we have 0.05 and 0.95. So let me just do the same things, 0.05 and 0.95. Okay, and once again, the probability of actually being pregnant is the probability of being truly pregnant and positive, so that's 0.05 times 0.98, okay, divided by everyone who tested positive. Now, I had erased it and I already forgot, so to find that, it's going to be 0.05 times 0.98 plus this group, which is 0.95 times 0.01. This is equal to 0.049. Okay, so we can already put that on top, 0.049, and on the bottom we have 0.95 times plus, so this is 0.0095 plus 0.049, and that's equal to 0.0585, and in this case 9 divided by 0.0585 is equal to 0.838. So in this case, because only 50 out of the 1,000 women were truly pregnant, even though you tested positive in this group, the chance of you actually being pregnant is even less, of 0.838. I mean, if you test positive for the pregnancy test, you're still likely to be pregnant, but there's also a good chance that you aren't pregnant.